This video goes along with the first part of reading in chapter 15. And in chapter 15, we are clarifying a lot of the ideas that we talked about in chapter 14. For example, the addition rule from chapter 14, we're moving into a general addition rule, much more powerful addition rule. Okay? In chapter 14, we require that the two sets were disjoint. Okay? And here we'll talk about when they're not disjoint, because they often are not disjoint. And the procedure to find A or B, this is the union or, is we'll take the probability that it is an A, okay, and we'll add it to the probability that it's in B. Okay, but you will notice in the picture that I just have double counted when it's an A and B. Okay, this part right here has been double counted. So, because I double counted it, I need to take it away once. Or in other words, if I take this part that's B and this part that was double counted, and I subtract the part that was double counted, I can put it back and I have exactly my union, or when A or B happens, where everything is counted only once. Okay, here is an example of in the book where that's done. So they take the probability that a student lives on campus plus the probability that the student has a meal plan, and then subtracts the probability that the student lives on campus and has a meal plan. Okay, so make sure you read through this example. These 4 example sections in the book are very useful. Okay, the next idea we talk about, before we talk about the general multiplication rule, because there is one, is about conditional probabilities. Okay, and hopefully you remember contingency tables, because it's kind of related to this idea of a contingency table. Okay, and conditional probability is the probability that something will occur given that some condition exists. Okay, for example, in the book they talk about the probability of a student that someone plays sports given that they are a girl. Okay, so whenever you see this vertical line, think about given that, and then the second thing is the condition. Okay, and the formula is down here. So the probability of that B will happen given that A has occurred is the probability that they both have occurred, which is this intersection right here, A and B, divided by the probability that A occurred, because that's the condition. Make sure you don't get those mixed up. Okay, so here's again an example from the book. These are very helpful, I think, in clarifying these ideas. All right, next we will talk about the general multiplication rule. Okay, and again, to compare this with chapter 14, where we required the events to be independent, here they don't have to be. Okay, so the probability that A and B both happen is the probability that A happens and B happens at the same time, or the probability that A happens times the probability that B happens given that A has already occurred. And I hope it makes sense that that's what we're looking for, because we want to look at A and B both happening. And so we're looking at probability of A and B given that A has also occurred. So I think that makes sense, but it's an important piece in this equation. Okay, which leads us into talking about independence. Okay, here's a formal definition, the one that we'll use in an equation for the rest of the year. Okay, A and B are independent whenever B given A occurs is the same as B happening whether or not A happened. Okay, so if A and B are truly independent, it doesn't matter whether or not A has already occurred. Okay, so here's again an example where we're looking at the probability of that a student has a meal plan given that they live on campus, and comparing that with the probability that a student has a meal plan. Okay, and if you calculate it, it's different. Okay, and so it's not independent. Okay, we wouldn't say it's dependent, it's just not independent. Students who live on campus who have a meal plan and those students who just have a meal plan. The last idea in this section is about independent versus disjoint. Now, these are two ideas that are different but are somewhat related. Okay, again, independent means that the probability of B is independent of A happening, and the probability that A happens is independent of B happening. So those two ideas are independent of each other. Okay, disjoint means that it is impossible for A and B to both occur at the same time. Okay, now one way that these two ideas are related is if I know that A and B are disjoint, then they cannot be independent. Because if I know that B has occurred, that changes my probability that A has occurred. Because if I know that B occurred, I know that A has not occurred because they're disjoint. Or vice versa, if I know that A has occurred, I know that B can't occur because they're disjoint. Okay, so because my probability is changing, given that I know that A or B has occurred, that A and B, if they're disjoint, they can't be independent. Okay, that's just one example of how these ideas are related, but more important than that, just know that they are separate ideas. Don't get them confused by being the same idea. They're different, separate ideas. Okay, and that wraps up our discussion for the first part of reading in chapter 15.